Hi, this is Kanchana Murthy, working as Assistant Professor in SNS College of Technology. In this session, we are going to see about process scheduling and synchronization. So in my previous video, we have discussed about readers, writers, and producer, consumer, and dining philosopher problems. So in this session, we are going to discuss about Sleeping Barber Problem. So we conclude our classical problems with sleeping barber. So imagine a barber shop with one barber, one barber chair, and waiting room with some n number of chairs. So the problem models a system that must handle ideal time efficiently. So if there are no customers, the barber should not pace around wasting energy. So he sleeps. That is, the process is blocked. When a customer arrives, they must wake the barber. That is, they need to send a signal. So if a barber is busy, the customer sits in a waiting chair. That is, the customer can enter into a queue. So if all chairs are full, the customer leaves. That is, it means it's a packet loss or rejection. So think of it as a web server. The barber is a CPU and the waiting chairs are request queue. If your server is overwhelmed and queue is full, the server drops the connection. So this is exactly what happens when a customer walks out of the barber shop. So there are some issues in sleeping barber. That is the coordination challenge. So that is race condition. So the biggest issue here is coordination. So imagine a customer walking in exactly when the barber is finishing a cut. So the customer sees the barber is about to be free and goes to sit down. Simultaneously, the barber checks the waiting room, sees no one has sat down yet, and goes to sleep. Now the customer is waiting for sleeping barber, and the barber is waiting for the customer to wake him up. So this is a deadlock caused by a race condition. So the solution is semaphore. So to fix this, we use 3 semaphores. First one is customers. For customer side, counts waiting customer. That is, the barber sleeps on this. Next one is for barber side, counts ideal barbers. The customer waits on this. Third one is mutex. So it ensures only one person checks the chairs at the time. So we must log the room and check the chairs and increment the customers count and unlock before the barber can react. So this ensures the checking and sitting are one atomic operation. So now that we have seen all 4 problems, let's look at your computer right now. So first one is producer consumer. So your GPU is consuming frames that your game engine is producing. Second one is reader writers. So your file explorer is ready folder names, reading folder names while you are trying to rename a file. Then third problem is dining philosopher. Your OS is trying to give 3 different apps access to your microphone, camera, and disk at the same time. Final one is sleeping barber. Your network card is sleeping until a data packet arrives to wake it up. So that is a database system in operating system and multi-threaded program. We are taking these problems into the attention. So next one is some questions. So let's test your knowledge. So if we have a system with 100 readers and only 1 writer, so which problem logic should be prioritized? So if we want fresh data, we favor the writer. If we want high throughput, we favor the readers. So understanding these trade-offs is what separates a junior developer from the senior architect. So discuss how starvation is often a choice made by the operating system to ensure most important tasks get done first. So answer it in the comment section. So let's summarize this session. Sorry. So over these 3 videos, we have covered synchronization, that is the art of managing shared resources, and semaphore, the tools, mutex and counting we use to signal processes, and the 4 problems, buffer management, shared access, deadlock prevention, and ideal state coordination. So every solution involved a mutex to predict the critical session and counting semaphore to manage the quantity of resources, right? So I highly recommend these references, and I have used these references for this presentation. So these books are called as Bibles of operating system. So finally, the you have to remember this: synchronization is the heartbeat of multitasking. So without it, our modern digital world would be a series of series of crashes and corrupted data. So thank you for watching my videos. So thank you.